Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video we're going to be measuring for the backfilling in the foundation for a frame structure. So this backfilling is kind of the soil that we would pour back into the foundation trench after we've laid our foundation footing and our block work. As you can see in this drawing, this is our foundation trench. You remember that we've calculated for the volume of excavation for our foundation trench, right? Now we need to determine what is the volume of material that we are going to be using to pour back into these spaces. As you can see, this point that I've marked with A, we need to pour materials into this point, and we need to pour materials into this point. So we need to determine what is the volume of material that we are going to be pouring at this point. So how do we go about calculating for the volume of this backfilling? Now this is how it is to be done. If you remember when you were doing your measurements as a beginner, when you are measuring for your foundation trench, right, under you would see something like anding on, or there's this sign that looks like and. Let me just do it here. You'll see this sign like this, anding on, and they will not tell you deduct backfilling and add material surplus. Now that nomenclature tells you that you are supposed to do something for backfilling, although it is not really calculated during that measurement aspect. But what that means is that when you are going to do your bill of quantity, you have to also measure for the volume of material that will be needed for that backfilling. I don't know if that makes sense. The nomenclature that says deduct backfilling and add material surplus is just to speed up the measurement process. But when you are now going to do your bill of quantity, because backfilling is also an item on its own that needs quantity for you to get the amount that will be needed for the backfilling, so you need to also calculate for the backfilling separately. So in this video I am trying to take my time to do everything properly so that in the future you will not have any problem. If not, I would have just gone ahead when we're measuring for the foundation trench, and I would have just done deduct backfilling and add material surplus and move to the next one. But I am trying to take my time so that you can understand this properly. So if you look at this diagram here that we have here, you can see that this box here is the trench that we have excavated. So I'm going to take you through the process so that you can understand how we want to go about measuring for this backfilling. Okay, so this is our ground level, or our strips level rather. So we've removed our top, so this is our strips level. So after that, we will now excavate for our foundation trench. So we excavated this part like this for our foundation trench. After excavating for our foundation trench, we now laid our concrete in the foundation. So this is our concrete in the foundation right here. And after laying our concrete in the foundation, after I set, we now started laying our block work. So now what we can now do to determine the volume of A and B is this. We've already calculated for the total volume of our excavation in our previous work. So all we're going to be doing now is from that volume of excavation in the trench, we are going to be minusing the volume of our concrete footing inside the trench, because the volume of our excavation is a meter cube. So we need to minus this volume here. If we minus this volume, whatever we have is going to be the volume of this box on top, this total box on top, moving to wherever the perimeter of the foundation trench is in the drawing. So like I said, we've determined the volume of our earthworks. We will now minus the volume of the column footing. Then whatever we have, we will now minus the volume of our block work. Now, if you look at this drawing, the block work exceeds the foundation trench or exceeds the street level. So we are only going to be taking conversant of the block work within the excavation. So from this point here down, we don't need this point because it is outside the excavation or it's outside the trench. What we are looking at is the block work inside of the trench. So it's more like, since we've gotten the volume of our excavation, we are trying to remove the volume of the obstacles inside the excavation. And what are the obstacles in this section? This, the concrete footing, and this, the block work. So we have to minus those volumes. When we minus those volumes, whatever we have would be the volume of A and B. I don't know if that makes sense. So now, if we follow this process, whatever we have left would be the volume for our backfilling for A and B. So if you want to determine the individual volume for A and B, you know that they are going to be the backfilling is poured at the spread or the foundation, and the spread of the foundation are equal. So whatever you have, you divide it by 2, one for this side and one for this side. I don't know if that makes sense. So with this, we'll now begin our measurement proper. So by the time we start our measurement, you are going to understand fully what is actually going on here. Another piece of information you should know before we move is that, remember, this is a frame structure. So we are going to be having the foundation trench and the trench for the column pit. So we are going to be backfilling for the both of them. So we are going to be using the same approach that I've said in the beginning, but there are going to be little intricacies when it comes to the measurement. So I need you to pay proper attention as we are doing the measurement. It is very easy. All you just need to do is to get the concept. So we are going to be measuring for 2 backfillings, the backfilling for the trench and the backfilling for the column pit. When we get the volume of these 2 items, that's for the trench and the column pit, we'll add them together because backfilling is one work item, right? When you are doing your bill of quantity, you don't separate the backfilling for the trench and the backfilling for the column. They are together, they are the same work item, so you have to add them together. So the first one we're going to be looking at is the backfilling for the trench. So we'll write backfilling for the trench. So the first thing I'm going to be doing now is that I'm going to bringing out the measurement that you did for the foundation trench excavation to get the volume of material that you'll be excavating for the foundation trench. And in our previous video, we said that the total depth of the excavation for the trench was 76.00 meters. The thickness, the width of the trench was 680 millimeters, 675 millimeters, so that's 0.68. And the total depth of the excavation will be calculated as 1025, which is 1.03. So just to get a quick recap, this is it here. So as you can see, foundation trench excavation not exceeding 2.0 meters deep. You can see this is the depth, 76.00, the width is 0.68, and the depth, we calculated the depth of the excavation as 1025, which is 1.03, and the total volume is 53.23. So 53.23, and then we close. So the next thing now we're going to be looking at is the deduction. So since we've gotten the total volume of the excavation, we now need to deduct, like I said, deduct the volume of the foundation footing. I don't know if that makes sense. I've already explained it in the beginning of the video. So we're now going to deduct the volume of foundation footing in the trench. So previously we calculated the volume of concrete in our foundation trench. So and in that video we said that we need 3 parameters because volume of concrete to the foundation footing is what measured in meter cube. So we need total perimeter of the concrete in the foundation, we need the thickness of the foundation footing, and then we need the width of the foundation footing. So we've already calculated our perimeter or our depth of the foundation footing to be 76.00, because it is the same depth that we are excavating that we are going to be laying our foundation footing. I hope that makes sense. So now it will now become 76.00. This is the perimeter, 76.00. And what is the width of the excavation? The width of the excavation is 675. So it means that if we are excavating 675, like it's had in this drawing, if we are excavating 675, it means that the width of the foundation trench would be as wide as the 675. So it will now become 0.68. The thickness of the foundation footing, as you can see in this drawing, is 225. So that's 0.23. And then you close. So you will now do the math. What do we have? So if you calculate everything, you are going to be having 11.89. So this is the total volume of the concrete inside the foundation trench for the foundation footing. So the next thing now we're going to be deducting would be the block work inside the trench. That is this block work from here to here. As you can see, the block work inside the trench. So how do we get the length of this block work from here to here? We know that we've already calculated in our previous video when we were doing the calculation for the foundation trench excavation. We said that the depth of the foundation trench we calculated as 1025. So if we want to get the height of the block work from this point to this point, all we need to do now is to minus the thickness of the footing. So if we minus the thickness of the footing from this dimension, whatever we have will be the height of the block work from this point down to this point. So 1025 minus 225 is equal to 800. So it means that the height of this block work from here to here is 800 mm. So with that we can now deduct for our block work. So we'll now say deduct 230 mm block work in foundation trench. So now you know that to measure for block work is in meter square, but we are trying to determine the volume of the block work. That's the volume. We need to determine the length, that's the thickness, the height, and the total perimeter that this block work will be laid in the foundation. I don't know if that makes sense. If you remember when we were measuring for our block work, let me use this point as a case study. The block work in the foundation is spanning from one column point to another column point. But we need to mind what we are looking for here is just the block work within the trench. As for the other parts that are within the column pit, we'll cater for that one when we are when we are trying to determine the volume of backfilling for the column pit. So all we need is just the volume of the block work inside of the what? Foundation what? Trench. So we're not going to be using the total perimeter that we've calculated in our block work, because for the block work we measured from column to what? Column. What we need is what? From the edge of the what? Foundation to the other edge of the what? Foundation pit. So the only way what we can use now is the total perimeter or the total length of the foundation footing that we've already measured for. Because if you look at this, if we want to get the total length of this block work here, it is the same thing as the total length of the what? Foundation trench here. And we've already measured for what? The total length of our what? Foundation trench. So as you can see in our previous calculated work for the foundation trench excavation, we said that the total perimeter of the foundation trenches was 75,958.5, which is approximately what? 76.00 meters. So it means that the block work that we are going to be using, or we are going to be laying for the foundation trench, the total is going to be what? The same as the what? Total of the what? Foundation trench itself. So we've already calculated as what? 76.00 meters. So we'll not book. So the first thing we are booking will be what? The total depth, which is what? 76.00. The next thing we're not going to be booking for would be what? The height of the what? Block work, which we've calculated as what? 800. So that's what? 0.80. And the next thing we're going to be measuring for is the thickness of the what? Block work, which is what? 230. That's 0.23. So with these, we'll get the total volume of the block work inside the foundation trench. I hope that makes sense. So we'll now do our math. 76 times 0.80 times 0.23 is equal to what? 13.984. So that's 13.98. So this is the what? Volume of our block work inside the foundation trench. So we're going to be deducting the volume of the block work inside the trench and the volume of the what? Foundation footing inside the trench from the total volume of the what? Foundation excavation, or the foundation trench excavation rather. So do the maths. 53.23 minus 11.89 minus 13.98. What are we having? We're going to be having what? 27.36. So this is the total volume of our backfilling for A and B. For both A and B in our what? Foundation trench. So now we know that our spread here is the same thing as our spread here. This beginner's measurement. You know that your spread must be what? Equal. So now if we want to determine what is the total volume for A, all you just need to do is divide it by what? 2. So this point now, the total volume for this point at A will be what? 13.68, and similarly at B it will be what? 13.68. So doing this, we've measured for the backfilling for the foundation trench. So the next thing we're going to be looking at will be the backfilling for the what? Column pit. So to measure for the backfilling for the column pit, we're going to be using the same approach as we did for the backfilling for the foundation trench, meaning that we need the total volume of our what? Column pit excavation. Then we're not going to be deducting the volume of the what? Column footing. Right? Once we deduct the volume of our column footing, we'll now deduct the volume of the block work inside each of the what? Column pits. Now, the block work inside the column pit is now where we have a little issue. So let's just take things slowly. First, we need to determine what is the total volume of our what? Excavation for the column pit, and then we will now deduct what? The total volume of the concrete for our what? Column footing. So let's start with that first. So just a quick recap, you can see this is our column pit excavation, and if you remember, this is what we did when we were trying to measure the total volume of our excavation for our column pit. So as you can see, the total volume we calculated was what? 42.89 meter cube, right? So this is the total volume of our what? Excavation. So we're going to be bringing it now to calculate for the what? Backfilling to the column pit. So the volume of our what? Column pit excavation is what? 42.89. So we'll bring this to the what? Squaring column, right? And then we close. So the next thing now we're going to be deducting would be what? The total volume of our what? Column footing. And our calculated volume for our column footing was what? 13.06 meter cube. Now where I got this 13.06 meter cube is from our previous measurement. So let me just take you back. So if you look at this was our leveling and compacting to the trench. I don't know, I'm looking for this particular one, this particular document where we did the measurements for the concrete for the column footing, but I can't find it. But we can also find our way using this. This is the leveling and compacting to the what? Column pit, right? And leveling and compacting measured in what? Meter square. So it means that this is the total area of our what? Column pit. 37.30, and in our drawing the thickness of our column footing is what? 350 mm. So if we multiply area by another parameter, it will give us what? The volume of our what? Concrete for the what? Column footing. So 37.30 times 0.35 is going to give us what? 13.055, which is approximately what? 13.06. So it means that the total volume of concrete that we'll be needing for what? The column footing is what? 13.06 meter cube. So that is how we got this our 13.06 meter cube. But you can go to the previous video when we measured for our concrete to our column footing, so that you can see if this is actually correct. So with this, the next thing now we're now going to be deducting would be what? Our block work inside the what? Column pit. Now this is where things get very tricky. First off, we are going to be defining our what? Dimensions for the what? Column pit. We know that for column pit 1, that's base type 1, the dimension was 1200 by 1200. For base type 2, the dimension was 1200 by 1200. For base type 3, the dimension was 2296 by 1200. For base type 4, the dimension was 2378 by 1200. And for base type 5, the dimension was 1400 by 1400. But now inside each of these column base, there is an intersection between 2 or more block works. So let's start with what? Base type 2, base type 1 and 2, because they have the same dimension, 1200 by 1200. So now if you look at this, for this base type 2, the dimension is 1200 by 1200, and you can see that there are 2 intersections of block work. That's one coming this way and one coming this way. We still have another one. Now the intersection is we're going to be using the center of the column point. That's this black this black stuff here, this which is our column, as the point of intersection. So we have a blockwork intersecting this column and another blockwork intersecting this column, meaning that there are what? Two intersections. Now if you look at this one again, base type 2, there's a blockwork intersecting the column, and there's another blockwork intersecting the column, making it what? Two intersections. Now if you look at this one, this is another base type 2 with a dimension of 1200 by what? 1200. But how many intersections are we seeing? 1, 2, and what? 3. Similarly, if you look at this one here, this base type 1, 1200 by 1200, and how many intersections are you seeing? 1, 2, 3. So what we are going to be doing now is basically this. We are going to be measuring the volume of the blockwork based on the number of what? Intersections that we have inside the what? Column pit. I don't know if that makes sense. So for base type 1 and base type 2, it is very easy. It's going to be straightforward because they have the same dimension of what? 1200 by what? 1200. So now the only difference is that for that base type 1 and base type 2, there can be two intersections. Some will have 3 intersections, some will have what? 4 intersections. 4 intersections in the sense like, look at this one here, 1, 2, 3, 4. So all we need to do now is to define them by the number of what? Intersections. So that's what we're going to be doing. So when we define them by the number of intersections, we are now going to be determining what? The total perimeter of what? This blockwork inside the column pit. So for example, now for the one of what? 2 intersections. Now if you look at this is the center. Through call out what? A. So the dimension, the center line from this point down to this point will be what? Half the length of what? Base type 2. So we know that the length of base type 2 is what? 1200. So it means that the dimension from this point down to this point of the blockwork will be what? 600. And similarly, from this center point down to the end of this blockwork here in the column pit will also be what? 600. So it doesn't matter if the intersection is what? Is given what? An L shape or a straight shape like this, as far as they have the same what? Dimension of what? Column pit. It is going to be what? The same. So we know that from here to here 600, from here to here 600, meaning that this obstacle here, the total length will be what? 1200, because 600 plus 600 is what? 1200. So similarly, we have this center. We want to determine the perimeter of this blockwork here. So we know that from here to this center line is what? Half the length of the what? Column base, which is what? 600, and from here to here is also half the length of the what? Column base, which is what? 600. So from here to here is what? 1200, meaning that the length of this obstacle here is what? 1200. I don't know if that makes sense. What we're going to be doing now is that we're going to be what? Bringing them out individually. We're going to be looking for what? The base type with what? A dimension of what? 1200 by 1200 with 2 intersections. So now we're going to be what? Counting. And this is what? 1, because it's base type 2, it has 1200 by 1200. This is what? 2. This is what? 3. This is what? 4. This is what? 5. Let me try and move this. This is what? 6. So there are 6 in number. We are not calculating this one because this base type was 5. So we are looking for the ones with 2 intersections that are base type 1 and 2. Because base type 1 and 2 have the same dimension of what? 1200 by what? 1200. So let's count again. So this base type 2 with 2 intersections, this is 1. Another base type 2 with 2 intersections, this is 2. Another base type 2 with 2 intersections, 3. base type 2 with 2 intersections, that's what, 4. So let's look for another base type 2 with what, 2 intersections, making it what, 5. Another base type 2 with what, 2 intersections, making it what, 6. So is there any other one? No. So it means that the base type with the dimension 1200 by 1200 with 2 intersections is what, 6 in number. So we'll now what, write 1.2 by what, 1.2 with 2 intersections is equal to what, 6 in what, number. And we said that the perimeter of the blockwork, that's the obstacle inside, if they have 2 intersections, is going to be what, 1200 in length. So the length will now be equal to what, 1200. So we'll now move to the next one. So the next one now is what, the column pit with 1200 by 1200 with 3 intersections. So we're not going to what, count. So let's just do it here. 1200 by 1200 with what, 3 intersections. So we now have to what, count. So no. So this base type 2, 1200 by 1200 with 3 intersections, this is 1. Another base type 2 with what, 3 intersections, this is 2. Another base type 2 with 3 intersections, this is what, 3. A base type 1 with 3 intersections, this is what, 4. A base type 2 with 3 intersections, this is what, 5. A base type 1 with 3 intersections, this is what, 6. A base type 2 with 3 intersections, this is what, 7. So is there any other one again? No. So there are what, 7 in number. Let's count again. So base type 1 or 2 with 3 intersections, that's what we're looking for. This is base type 2 with 3 intersections, 1. Base type 2 with 3 intersections, 2. Base type 2 with 3 intersections, 3. Base type 1 with 3 intersections, 4. Base type 2 with 3 intersections, 5. Base type 1 with 3 intersections, that's what, 6. Base type 2 with 3 intersections, that's what, 7. So this is making it what, 7. So they are what, 7 in what, number. So now what, book. So now what will be the length? So to determine the length, let's just use this one as an example. We know that we've already calculated the length for 2 intersections as what, 1200. So it means that the dimension from here to here is what, 1200, meaning that this obstacle here will have a length of what, 1200. So now we want to determine what is the length of this other one here. Now we're not going to be starting from the center line. If we start from the center line, by the time we do our measurement, we now have to deduct for this little half here. Instead, so that we don't waste our time, we are going to be starting from the edge of the what, column to this other edge. So it means that we would have gotten the what, total volume for this side, and then we'll now just add this volume here. I don't know if that makes sense. So now we've gotten the length of this blockwork here as 1200. So we need to determine what is the length of this smaller one here, starting from what, the edge of the what, column itself. So now, since we know that from the center line to this point is half the length of the dimension of the column pit, so which is what, 600, right? We'll now minus half the thickness of the what, column. So when we minus half the thickness of the column, whatever we have will be the dimension from the edge of the column down to this what, edge of this blockwork. So we said that the dimensions for the column is what 230 by what 230. So 230 divided by 2 is what 115. So it means that half is 115. So since from the center line to this edge is 600, we'll now minus what 115 from 600. We are going to be having 485. So we'll now add 485, which is the length of this small block work here, to the length of this straight block work, which is what 1200. So 1200 plus 485 is equal to what 1685. So it means that anyone that has 3 intersections and it is a base type 2 or a base type 1, the length of that what 3 intersections is 1685. So now what book 1685. So this is the length of the what obstacle for a base type 1 or a base type 2 with what 3 intersections. So the next now we are going to be looking at is what a base type 1 or a base type 2 with what 4 intersections. So if the length of the column pit is 1200 by 1200 with 4 intersections, then we now have to what count them. So we'll now start base type 2 or base type 1 with 4 intersections. So this is a base type 1 with 4 intersections. This is 1, 1, 2, 3, 4. So this is making it what 1. So this is a base type 1 with 4 intersections. As you can see, cross this, 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 and this. So this is making it what 2. And the last one is what this one here. This is a base type 1 with 4 intersections. 1, 2, 3, 4, making it what 3 in what number. So we'll now what book. So they are what 3 in what number. So we now need to determine the length of that what 4 intersections. So now for that of 3 intersections, we said that the smaller part, which is here, the smaller part here is what 485. So for the 4 intersections, it means that this smaller part is going to be in what 2 sides. So now what we're not going to be doing is this. Since we know that here is 1200, here is 485, that means the next one here to make the cross will be what another 485. So now this is what I mean. We know that this length is 1200. This one we've calculated as 485. So this 485 will be the same thing as this one here, 485. So now to get the total length of this cross will now become what 1200, which is the length of this straight one here, plus 485, which is what the length of this one here, plus another 485, which is the length of this what one here, and that will be equal to what 2170. So it means that for a base type 1 or 2 with 4 intersections, the length, the total length of that obstacle is what 2170. It doesn't matter how they come, as far as it's 4 intersections. Like for example this one now, it's still going to give you the same 2170. It's just that instead of this block work to be here giving it a cross, they just extended it to the top. So we'll now what record 2170, and then we close. So the next one we're going to be looking at is what base type 5 with 2 intersections. And we know that the length of base type 5 is what 1400 by what 1400. So base type 5 is 1400 by 1400. So we'll now count. So you have one here and you have another one here. So it means that base type 5, that's 1400 by 1400 with 2 intersections is what 2 in number. So we'll now what record. You can say I've recorded this 2 in number. So the next thing now we have to do is to determine what is the length of what the intersection, that's this block work inside, we need to determine what is the length. So as you can see in call out 7 is passing through the center. So it means that from here to here will be half of the length of what the length of column base 5. So we know that the length of column base 5 is 1400, so half will be what? 700. So if from here to the center point is 700, similarly from this center point, which call out C, down to this other edge will be what? 700. So it means that the total length for this L shape is going to be what? 1400. So we'll now what? Record that the length is equal to what? 1400. So the next one we're going to be looking at is what? Base type what? 5 with 3 intersections. So we'll now what? Write 1.4 by 1.4 with what? 3 intersections. So 1.4 by 1.4 with 3 intersections will now what? Count. As you can see, this is the only one we have. A base type 5 with what? 3 intersections. That's this 1, 2 and what? 3, making it what? 3 intersections. So it is 1 in number. So we'll now what? Record. So what is the length of this what? 1? So we know that we've said that with 2 intersections it is what? 1400. So it means that this straight one here, we can use it as what? 1400. So we need to determine what is the length of this particular one here. So we know that from this call out 6 passing through the center down to the edge of the what? Column base is what? Half of what? The length of the column base. So if from here to here is 1400, half will be what? 700, meaning that from this center point down to the edge is 700. So we need to minus what? The thickness of what? This column at this shorter side, and we said that this shorter side is what? 230. So half of 230 is what? 115. So we have to minus 115 from 700 to get the total length of what? This block work here. So 700 minus 115 is equal to what? 585. So 585 is the length of this block work here, this small one. So we'll now add this to this what? Block work here, which we've calculated as what? 1400. So plus 1400 is equal to what? 1985. So we'll now what? Record. So the length is equal to what? 1985. So the next one we're going to be looking at is base type 3. And the dimension of base type 3 is what? 1200 by what? 2296. So approximately what? 2.30. So 1.20 by what? 2.30 with how many intersections? With what? 2 intersections first. So with 2 intersections, so we have to what? Count. So this particular word base type is what? Base type 3. So now normally we know that this base type 3 has multiple intersections. We have 1, we have 2, we have 3 and we have 4. But we have to make things easy for ourselves. We are going to be taking it as what? 18. So this is this and this is what? This. So first things first, we are going to be determining what is the length of this one. I'm going to be determining what is the length of this one. And as you can see, we have this particular type in 2 places. So they are what? 2 in number. So we're going to be saying that this is what? 2 intersections. So this is 1, this is what? 2. This is 1, this is what? 2. So they are what? 2 in number. So we need to determine the length. So now we know that this shorter side is 1200, meaning that from here to this point is what's going to be what? 1200. So now we need to determine what is the length of this longer side from the edge of the column down to this edge of the what? Column pit. And now how do we do that? We know that from this point down to this point is given as what 2,296. So what we can do now is to minus this point here, and in our drawing they've given it to us as what 600. So if you look at this drawing, this base type 3, they told us that from this point down to this point is what 600. So what we can do is this. As you can see, they've even made it easy for us in the drawing. They've told us that from this point to the edge of the other column is what 1096, and from this edge to the other edge is what 600. So 1096 plus 600 is equal to what 1696. So it means that from this center point down to this edge is going to be what 1696. But mind you, we have to minus what the half of what the thickness of this column, because it is intersecting and we don't want to stress ourselves to start doing deduction. So we have to do the deduction now. So we'll be minusing what this half of the what column. So the column is what 230. So we'll now half will now be what 115. So 1696 minus 115 is equal to what 1581. It means that the dimension from this edge down toward this edge of this block work is 1581. So we'll now add it towards this length that we have for this straight one. So and we said that this length is what 1200. So plus 1200 will be equal to what 2781. So it means that the dimension for this T block work here is 2781. So we'll now what record. So the next one we're going to be looking at would be what 1200 by what by 2378, and that's base type what 4. So we'll now what right. So this is what 1.2 by what 2.38, which is base type what 4. So with how many intersections? With 2 intersections. Do we have one with 2 intersections? No, we don't have one with 2 intersections, but we have one with 3 intersections. So this is 1, this is 2, and this is what 3. But we're going to be making things easy for ourselves. We're going to be turning these to 2 intersections so that we can cater for this one, and then we can cater for this longer one. So we can now see what with what 2 intersections. So how many are they in number? It is just 1. So it is 1 in number, because this is the only one we have in the drawing, just this one. So to determine the length of what this L-shaped block work here, we have to determine the length of this part from this center point, this colored A, down to the edge. So we know that the length for this shorter side of the base, the column piece, is 1200. So half of it will be what 600, since colored A is passing through the center, meaning that from this point to this point is what 600. So similarly, we have to determine what is the length from this point down to the what center line for the longer side. And as you can see in this drawing, they've told us that from this point, this center point down to this center point is 1178, and from this center point to this edge is what 600. So you have to add everything together. 1178 plus 600 is equal to what 1778. So it means that the dimension from this point to this point is 1778, meaning that the length of this block work for this longer side from this edge down to this center point is 1778. So we'll now add that towards this shorter side, which we calculated as was 600. So plus 600 is equal to what 2378. So it means that the total length of this L-shaped block work is 2378. So we'll now record. So the length is what 2378. So with this, we've already gotten the dimension of all the block works intersecting inside the what column pits. So what we're now going to be doing now is we're going to be trying to guess the volume of those block works, and then we'll now be deducting it from our our calculated volume of the excavation for the column pit. So let's get right into it. So to get the volume of these block works inside the column pit, we've already determined the length. So the next parameter we're going to be needing is the thickness of the block work, which is 230 mm. And then the next parameter which we'll be needing is the height of the block work. So to determine the height of the block work, if you remember in our previous calculation, this is the calculation for the column pit. We've already done the depth of the excavation, right, to be 1150. So it means that if this were to be the diagram for our column pit excavation, this would be 1150. The thickness of our column pit, the thickness for our column footing is given as 350. As you can see in this drawing here, 350. So what we are going to be doing now to get the total length of this block work is as the same that we did in our foundation trench. So 1150 minus the thickness of the column footing, which is 350, will give us the length of this block work. So 1150 minus 350 is equal to 800, the same as we got in our foundation trench for the block work. So we will now record. So we'll now start with this first one. So the length is 1200, which is 1.20. The thickness is 0.23, and the depth or the height of the block work is 800, which is 0.80. And then we close. So 1200, which is 1.20, multiplied by 0.23, multiplied by 0.8, then multiplied by 6 number, is equal to 1.32. So the total volume of the block work, so the total volume of all the 6 block works with 2 intersections inside this particular column pit is going to be this. So we'll now move to the next one, the one with 3 intersections. So the length is 1685. So 1.69 by 0.23 by 0.80 by how many in number? 7. By 7 in number, and then we close. So now do the calculation. 1.69 times 0.23 times 0.80 times 7 is equal to 2.176, approximately 2.18. So we'll now do the next one. 1.2 by 1.2 with 4 intersections. So the length is 2117. So 2.17 by 0.23 by 0.80 by how many in number? 3 in number, and then we close. So we'll do the maths. 2.17 times 0.23 times 0.80 times 3 is equal to 1.197, approximately 1.20. So we'll now move to the next one, which is this one, the 1.4 by 1.4 between intersections. So we've already calculated the length as 1.40. So 1.40 by 0.23 by 0.80 multiplied by 2 in number, and then we'll close. So 1.40 by 0.23 by 0.80 multiplied by 2 is equal to 0.515, approximately 0.52. So we'll now do the one with 3 intersections. The length is 1985. So this is 1.99 by 0.23 by 0.80, and it is one in number, so we'll now what close. So 1.99 times 0.23 times 0.80 is equal to what? 0.366, approximately what? 0.37. So we'll move to the next one, which is 1.2 by 2.30 with two intersections, and they are two in number. The length is 2781, so that's 2.78 by 0.23 by 0.80, and they are what? Two in number. So we'll do the maths. 2.78 times 0.23 times 0.80 is equal to what? 0.5115 multiplied by what? Two in number, which is 1.023. So this is 1.02. So the last one will not be what? The last one will not be what? This one. 1.2 by 2.38 with two intersections, one in number. So to be 2.38 by 0.23 by 0.80, and then we close. So 2.38 times 0.23 times 0.80 is equal to what? 0.437, approximately 0.44. So doing this, we've calculated the total volume of what? All the block was inside the what? Column pit. So what we'll now do now is that we're going to deduct it. We're going to do all our what? Deductions. So this is the total volume of what? The excavation for the column pit, 42.89. We're now told to deduct what? Volume of the column footing, which we calculated as what? 13.06, sorry. Then we'll now start deducting what? All the volumes of the block work we've calculated. So the first one is 1.32. The next one is what? 2.18. The next one is what? 1.20. The next one is what? 0.52. The next one is what? 0.37. The next one is what? 1.02. The next one is what? 0.44. So when you do the math, you're going to be having 22.78. So 22.78 is the total volume of what? Material that you're going to be needing for what? Backfilling to the what? Column pit. So we'll now what? Book. So we'll now do our what? Summary. So to do our summary, we have to add the total volume of backfilling we've done for our trench and the total volume of backfilling we've done for our what? Column pit together. So we'll now write total backfill trench will now be equals to what? We've measured it as what? 27.36. So the next one, total backfill to column pit, we've calculated as well 22.78. So when you add the two of them together, 22.78 plus 27.36 is equal to what? 50.14. So 50.14 is the total volume of what? Material that you're going to be needing for your backfilling for both the foundation trench and for both the what? Column pit. So with this, we've measured for what? Our total volume of materials for our what? Backfilling for the foundation. So with this, we've come to the end of today's video, guys. I hope you derived adequate knowledge from it. Please, if you don't understand any piece of information that I have done here, please, I would like to see them in the comment section so that I would answer them properly. Thank you for watching, and without any further ado, we've come to the end of this video.